The problem shows us a circle of radius 4 and asks us for the area of the square enclosed between two radii and the circle, that's all. If you already have an idea of how to solve it or want to give it some thought, this is the time to pause, because now comes the solution. The key to the solution, and to a lot of other geometry problems, is to draw a new segment, in this case, the diagonal of the square. But if we draw it in this direction, it would not be useful because we do not know the length of the sides of the square or the diagonal. On the other hand, if we draw it in this other direction, we see that it is identical to the radius of the circle, whose value we know and can use to solve the problem. Since the diagonal divides the square into two right triangles, we can call x the side of the square and apply the Pythagorean theorem to the lengths of its sides. We have x squared plus x squared equals 4 squared, or 2 times x squared equals 16. And if we divide by 2 on both sides of the equation, we have x squared equals 8. We don't need to solve for x because what we're looking for is the area of the square, which is exactly x squared. So the result is 8, and may it rest in peace. Now, this is a problem that we can generalize for any value of the radius. Let's call r the radius. Then the Pythagorean theorem tells us that x squared plus x squared equals r squared, or 2 times x squared equals r squared, and therefore x squared equals r squared divided by 2, which would be the value of the area for any value r of the radius. Finally, may the problem rest in peace. See you for the next one.